What's up, guys? Welcome back to Mu Galileo. This is 8.8, Improper Integrals. Hope you did the homework. This is new stuff. Let's get right into the video. All right, so we're talking about improper integrals, and so we need to remember everything we've done before. So we sometimes have to integrate by parts. Sometimes we have to use L'Hopital. L'Hopital is when we get indeterminate forms, and we got lots of different indeterminate forms: 0 over 0, infinity over infinity, 1 to infinity, 0 to infinity, all those good things. So let's practice. So now we have the integral from 1 to infinity of the quantity 1 minus x e to the negative x dx. And so when we take an integral, we're actually finding what? Area under a curve. However, this is unbounded area because we're going to infinity, and so that's what makes things improper. That is one of the ways that make it improper. So how are we going to integrate this one? Okay, we're going to take a limit as b approaches infinity. Totally. All right, but then we're going to use tabular. Exactly. So I'm going to derive, and I'm going to integrate. And so which part am I going to derive? The 1 minus x. I'm going to pick my polynomial part. And so what would be and so I'm going to integrate e to the negative x. And so what is my derivative of 1 minus x? Negative 1. I'd like to go one more. So what do we get? 0. And so I can get to 0. I'm going to go to it. And so then what's my antiderivative of e to the negative x? Negative e to the negative x. And then what? E to the negative x. And so then it's tic-tac-toe, so we go plus minus plus, even though we won't get to that part. So we're going to go that way. And so now I have a limit as b approaches infinity of what is my integral? It'd be the quantity of 1 minus x, and then I'd have times what? Negative e to the negative x. So I have e to the negative x. I'm going to tack on a negative out front there. And then I'd have what? Plus e to the negative x, because I have a negative going on. And so now I'm going from 1 to b. And so now I'm basically just substituting in b, which is technically kind of like infinity. And so this is my childhood. So this is like e to the x on the bottom. Is everybody following me? And so when I substitute in b, or really substituting in infinity, I have a poly up top, and then I have an exponential on the bottom. And so who wins? The exponential. So what does that go to? 0. And then plus, what's that part going to go to? When I substitute in infinity here, that's also going to go to what? 0. And then minus, now I'm going to substitute in 1. And so when I substitute in 1, what do I have in my numerator now? 0 over e, which is what? What kind of number? 0. And then plus, and then I'd have what? When I substitute in 1 right here, I'd get what? E to the negative first, which is what? 1 over e. And so now, what do I get? I get negative 1 over e. And so it converges to that. Very good. All right, so it converges to negative 1 over e. Now, here's my graph of it. All right, here's my graph of it. And so what it's doing is finding my area of my unbounded region because it goes to infinity. Now, does it ever touch 0? No, it never touches y equals 0. However, it adds up quick enough so it converges to that amount. Why is it negative? Because it's underneath my x-axis. All right, so we're going to talk more about improper integrals. So what we've been dealing with right now is limits to infinity. All right, and so infinity is definitely improper. However, functions can break at other points as well. And so functions break at like vertical asymptotes and things like that. All right, or holes and so forth. So we have to take care of that. All right, so let's look at this next one. So now I got negative infinity to infinity of e to the x over 1 plus e to the 2x dx. So how many things do I have going on here? How many improper things do I have going on? I got 2, and I have to deal with both of them. I have to deal with both of them now. And so what we actually want to do is we want to split up my integral. And so I can pick any number. It really does not matter what number we pick. So we go negative infinity to 0. Let's do 0 then. All right, and so we go from negative infinity to 0. of e to the x over 1 plus e to the 2x dx. And then I'm going to go from what? The integral from 0 to infinity. Now, it really does not matter which number you pick. All right? Now, you guys look like you split it in between. You split it halfway. That's cool. However, we don't have to split it exactly halfway. We could pick 2. Okay, does that make sense? Okay, so we can pick anything we want. All right, and so now I have an improper, and so this negative infinity breaks it, and this infinity breaks it. And so we're going to take 2 limit statements after we take an antiderivative. So I'm going to have a limit as b approaches negative infinity this time. And so let's talk about my integral. So what is my integral going to be? It's an arctan, exactly. And so this is set up as like an a squared minus our u squared. And so what is my u? E to the x. And so that's why it's u squared. And so what would be my du? E to the x. So that's what got covered up here. And so this is just an arctan of e to the x. And I'm going from b to 0. And now we need a new limit statement. And because we're in BC, I'm just going to say it's a limit as c approaches infinity now. And so now we'd have arctan of e to the x, and I'm going from 0 to c. So now we're going to substitute in 0. And so we'd end up with arctan of what? 1. And we can actually evaluate that one. What is arctan at 1? Pi over 4. However, if you just had it as arctan of 1, it would actually cancel out. We'll show you why in a second. And then what? Minus. Now we're going to substitute in what? Negative infinity. And so now it's e to the negative infinity, which is actually what? 0. And so now we're doing arctangent at 0. And what is arctangent at 0? 0. And now we're going to add it with the next part. And so now we're doing arctangent of infinity, basically. So now it's e to the negative or positive infinity, which is what again? Infinity. So when is arctangent at infinity? At pi over 2. And then minus, now we're substituting 0. And so this is why it's going to cancel out every time. And so when we do this one, we're going to get what again? Pi over 4. And so no matter what you actually substitute, those points in which you pick, we picked 0, those are going to cancel out. All right. And so if we pick 2, like if we just randomly pick 2, then we'd have arctan of 2, and then we'd have minus arctangent of 2. And so guess what happened? They canceled out. And so guess what we'd end up with? Pi over 2. And so what do we actually want to say to it? It converges to pi over 2. All right. And so now, when we're actually doing improper integrals, we need to think about sometimes they break in the denominator and they create a vertical asymptote. And so we need to go from either the left or the right of those vertical asymptotes. And so, for instance, if we're on the right side of an equation, we have like a vertical asymptote going on there. This one would have to be approached from the which way? The right side. Okay, I can't actually just evaluate it. I need to approach it from the right, and vice versa. So if we have a function that's going that way, it's going to break at this point, and I'd have to approach from the what? The left. And so that's why we need these one-sided limits when we're dealing with those discontinuities. All right, let's play. Here we go. So now we have the integral from 0 to 1 of dx over the cube root of x. On this one, what breaks on this integral? 0 breaks. 0 breaks. However, let's think about what side we are making this from. It's going to be from the what? The right side. It's going to go from the right side. And so I like to take an integral right away. But my limit is going to be as b approaches 0 from the right, because that's what makes it improper. It's from the right because it's between 0 and 1. I'd have to go from the right side of it. All right. All right, so now what is my antiderivative? What do I want to think of this x to the cube root x thing? Negative 1/3. And so when I take an antiderivative, now it's x to the what? 2/3. So now it's x to the 2/3. And then what comes out front? 3/2. Very nice. And so now I'd have from b to 1. Cool. Cool. And so now when I just substitute in 1, what do I get? I get 3/2. And then minus, now I substitute in b. And b is 0 from the right. And so if I were just to substitute in 0, it would be fine. It won't break here. And so when I substitute in 0 from the right, or 0, what do I get? I get 0. And so what do we know? It converges to what? 3/2. All right, cool. Let's do some more. So let's look at this guy. So now I have an integral from 0 to 2 of dx over x cubed. Again, when does this function break? At 0. So I'd like to write my limit statement right now. So now if I have a limit as b approaches 0 from the what way? From the right. It has to be from the right in this case because it's going between 0 and 2 and it's breaking at 0. All right. And so then how do I want to think of this integral? It's really x to the what? -3. So let's add a power, divide by it. So what do we get? So -1 over 2x squared. And I'm going from b to 2. All right, cool. All right, and so now when I substitute in 2, what do I get? I get -1/8. Minus, now I substitute in 0 from the right. Well, if I just substitute in 0, what happens? It breaks, okay? And so if I go from the right, I have a negative number over a really small what? Positive. And so what's a negative over a really small positive? It's negative infinity. And so what happened? It diverges technically to what? Positive infinity. And so it keeps adding up forever. It doesn't stop adding up. It doesn't add up quick enough. And so that's why it diverges. So on this one, we have an integral from 0 to infinity of dx over the square root x times x plus 1. All right. And so this is actually a double improper integral. Because why? It's going to break at what? 0 and positive infinity. All right. Technically, it would break at -1 too. Let's talk about it. Why do we not care about it breaking at -1? Technically, it does. Because it's not on my interval. Okay. But technically, it would include -1 if it were on my interval. All right. That's a good nugget. Let's split up my integral. So what do we want to go from? So let's take a limit as b approaches 0 from what? The right of b to what number do we want to pick? 5. I like 5. That's good. And then we'd have dx over the square root x times x plus 1. And then we'd have plus. Now I'd have my limit as c approaches infinity of my integral from what? Now we have to start out at what? 5 to c of dx over the square root x times x plus 1. All right. And so now let's think about what kind of integral is this? This is a fancy manipulation. My u is equal to square root x. And so what would be my du? 1 over 2 square root x dx. And so actually this part right here gets covered right here. And so this part is actually a what? A square root x quantity squared plus 1. And so really it's a what kind of antiderivative? It's an arctan again. All right, so this is actually an arctan. However, what needs to be brought out front? Not a 1/2, but a 2 when I antiderive. And so now I'd have a limit as b approaches 0 from the right of 2 arctan of square root x from b to 5. And then I'd have plus my limit as c approaches infinity of 2 arctan square root x from 5 to c. Now we're going to substitute in what, Nathan? 5, good. And so now we'd have 2 arctan of square root 5. Does anybody know what that is? Me either. So I'm going to say it's 2 arctan of square root 5. And then minus, now we're going to substitute in 0. And technically it's 0 from the right. And so what do we get? What is arctangent of 0 from the right? It'd be 0. And so now I have minus 0. And then plus, now I would substitute in what? Infinity. If I square root infinity, what happens still? Still got infinity. And so now I have 2 times what? Pi over 2. And then minus, now I'm going to substitute in what? 5. And so now I have 2 arctan of square root 5. And so what beautiful thing happens? Those cancel. So it doesn't matter what we choose, they will cancel. All right. And so what are we left with? Pi. We are left with pi. All right. And so it converges to pi. And so we have that kind of function, which is so cool, because guess what? It went to 0 fast enough, and it went to our vertical asymptote fast enough that we had a convergent area. All right. And we're done with chapter 8.
Thank you guys so much for watching 8.8 Improper Integrals. Make sure you smash like, subscribe, and hit that bell for new bangers. See you next time.